Hi, I'm Brooke Hollingshead, and this is the first video demonstration for Math 500. Today we're doing an epsilon delta proof, and I'm going to start by talking to you about the epsilon delta definition. So the epsilon delta definition states that for any epsilon greater than 0, we have a delta value greater than 0, so that if the distance between x and a certain x value, so between x and a, is within delta, then the distance between our function and the limit is going to be within epsilon. So we're attempting to use a limit. We're trying to find a value so that as x gets really close to a certain value within a little delta value, we're going to pick the delta value. As x gets within a little delta value, then the function gets within its limit, gets within an epsilon value of the limit. Okay, so quit talking and rambling. So the one that we're proving today is that the limit as x approaches -3, so this is going to be our a, of the function 2x squared plus fx plus 5x plus 7, that the limit is 10. So this is what we're proving today. So we're actually going to go backwards to start. So normal proofs, you start with the if, and we say that if we've got this, then we end up at this, and then we're done with our proof. We're going to start here to do a little bit of background work on it to find a delta that'll work for us, so that then we can go into the proof using the delta that will work for us and have everything be all nice and neat. All right, so we are going to have some side work that we have to do first. All right, I apologize that I have to write across the screen. All right, side work. So we're going to start with our, like I told you, we're going to start with our then. So our f of x minus the limit is less than epsilon. And our f of x is 2x squared plus 5x plus 7. Our limit is 10. Is less than epsilon. All right, do the math. 2x squared plus 5x minus 3 is less than epsilon. Factor that out nicely. 2x minus 1, x plus 3, less than epsilon. Okay, in our absolute value rules, we get two different factors here. So x plus 3, absolute value, and 2x minus 1 absolute value. Well, the x plus 3 is awesome because that's our limit is heading toward -3. So that's the one that's going to be awesome for us. We're going to use that one to figure out what we want for this other one then. All right, so the x plus 3, we're going to make that real small. So we've got a distance that's real small. And we can choose it. I'm going to say 1. That's what we normally choose. That's what's been chosen in class. So if we say 1, it's less than 1. That'll be pretty small. Let's do the math on this. Okay, and then I told you that we're going to use this one to kind of make 1 for the other one. So I'm going to get to 2x minus 1. All right, multiply everything by 2. So I end up with 2x plus 6 is less than 2. Then to get to -1, I need to subtract 7. So I'm going to subtract 7 everywhere. 2x minus 1, -5. Okay, the rule of our absolute value says the maximum absolute value from either side is what we're going to use. So maximum absolute value is it going to be -9 or maximum absolute value is going to be -5? Nope, it's going to be the -9, which absolute value is +9. So this ends up being less than +9. All right, so if this is going to be 9, then let's figure out, so absolute value of 2x minus 1 times absolute value of x plus 3. I need this to be less than epsilon. Well, if this one is 9, then I can choose the other one to be epsilon divided by 9 so that the 9's cancel and I end up with a really nice epsilon there. Okay, so if I can use epsilon over 9 as my delta value for x plus 3, then it'll work really nicely with the 9 that I chose for this one, and I'll end up with epsilon. All right, let's do our proof then. First, we need to say that epsilon is greater than 0 because that is our conditional in our definition. So I'm going to choose the minimum of either 1 or epsilon over 9 for our delta, because if we choose the smaller one, then we make sure that we are within that distance. So I'm going to say then the x plus a is less than delta. So I'm going to say x minus a is less than delta. Minus a would be x plus 3 then is less than 1. Do the math. This looks pretty familiar. We're going to end up multiplying everything by 2 so that we can get to a very handy place, subtract 7, where this looks like one of our factors. Okay, 2x minus 1 is less than 9. Also, if we use the other one that we said we could have, how about the epsilon over 9? Well, then 2x minus 1 absolute value times x plus 3 absolute value. We said the first one is 9 and the second one is epsilon over 9. Ta-da, it did what we wanted it to. So this is actually just going to be less than epsilon. All right, let's do some math over here. 2x squared plus 5x minus 3. Oh, let's see. If we do 2x squared plus 5x and we add 7 and then subtract 10, that's the same thing. But ta-da! This is our f of x, and this was our L. Statement proven.